Hello everyone, I'm Dr. Sonia Kaur Bansal and welcome to Gyanbihar School of Education, and today's topic in the subject methodology of educational research, my topic is F-test. So we are going to study about F-test as what is F-test and what are its uses. So today's learning objective of my class is to enable you all students about the F-test understanding, its concept, how it is used in research process, and what are its assumptions, characteristics, and of course formula, and how it is being interpreted. So just let's understand it in a very relaxing way. So let's start it. F test, or it is also called variance ratio test. All right, students, variance ratio test. So now F-test or variance ratio test is the test based on the test statistics which follows F distribution. It is called F-test. So analysis of variance, ANOVA can determine whether the means of three or more groups are different. So when we are doing a research, students, so in that research, we are actually having more than one or two groups or three groups, then we use the F-test. So F-test is basically, ANOVA uses F-test to statistically test the quality of means. All right. So now let's understand it further. What are the F-test, F-statistics, and the F-test? So F-test are named after its test statistics. F, it's a letter F which was named in the honor of Sir Ronald Fisher. And I would like to suggest my all MEd and B.Ed students just to remember this name, as this is the most important question when you receive MCQs in your NET or any competitive exams, such as by whom F-test was given, by whose name it is honored. So the correct answer would be Sir Ronald Fisher. The F statistics is simply a ratio of two variances. Variances are a measure of dispersion, or how far the data are scattered from the mean. Larger values represent greater dispersion. So just understand, students, that when we take out the mean value, but mean value is simply that where is the what is the average, or where is the data is there. But variances are something that measures the dispersion of data, as how it is scattered around the mean variance. So larger values represent greater dispersion. Variance is the square of the standard deviation. Now understand what is variance. So variance is the square of the standard deviation. For us humans, standard deviations are easier to understand than variances because they are in the same unit as the data rather than squared units. So just understand it in that simple way, that what is the variance? Variance is the square of the standard deviation. So however, many analyses actually see variances in the calculations. All right, students, so it has to be understood in that way. Now, let's understand further. F statistics are based on the ratio of mean squares. So, whatever the mean squares we have achieved in our data collection. The term mean squares may sound confusing to you, students, but it is simply an estimate of population variance that accounts for the degrees of freedom, that is DF. Degrees of freedom is called DF. So used to calculate that estimate. So despite being a ratio of variance, you can use F-test in a wide variety of situations. There can be many situations when you are investigating a project or you are doing the research. And unsurprisingly, the F-test can assess the equality of variance. I again repeat, what is the variance? Variance is the square of the standard deviation, as I have explained you this in my last slide. So square of the standard deviation is called variance, and when we are actually applying the F statistics. So just remember that F statistics is based on the ratio of mean squares. Okay, so the term mean squares may sound confusing, but it is simply an estimate of population variance that accounts for the degrees of freedom used to calculate the estimate. Now, despite being a ratio of variances or the square of standard deviations, you can use F-test in a wide variety of situations. So, unsurprisingly, students, the F-test can assess the equality of variances. However, by changing the variances that are included in the ratio. So, the F-test becomes a very flexible test. For example, you can use F statistics and F test to test the overall significance for a regression model also, to compare the list of different models, to test specific regression terms, and to test the equality of means. So just understand how we are going to use the F test. Now, using the F test in one-way ANOVA. So how it is working, one-way ANOVA. So to use the F-test to determine whether group means are equal or not. When we are talking about group means are equal or not, then we are discussing about that it's just a matter of including the correct variances in the ratio. In one-way ANOVA, the F statistics is this ratio. F variation between sample means variation within the sample. So just remember, students, F variation between the sample means variation within the sample. So F equals to variation between sample means how much variation is there. Variation within the sample or variation between the sample means. So just remember this in that way. So in that case, we are using the F test. Okay. Now, F test is conducted by the researcher on the basis of F statistics. So F statistics, the F statistics is defined as the ratio between the two independent chi-square and between the two independent chi-square variates that are divided by the respective degree of freedom. The F-test follows the Snedeker's F distribution. All right, students. So just understand it in one more way. An F-test is conducted by the researcher on the basis of the F statistics. The F statistic is defined as the ratio between the two independent chi-square variates that are divided by their respective degree of freedom. The F-test follows the Snedeker's F distribution. The F-test contains some applications that are used in statistical theory, which this document detail the applications. So the F-test contains some applications that are used in statistical theory. This document details the applications. Now students understand further about F-test. The F-test is used by a researcher in order to carry out the test for the equality of the two population variances. It means you have two set of different population and you have variances of it. Variances means squares of standard deviation. So squares of standard deviation, if a researcher wants to test whether or not two dependent samples have been drawn from a normal population with the sample same variability, then he generally employs the F-test. All right. So understand, if a researcher wants to test whether or not two independent samples have been the same variability, then he generally employs the F-test. So the F-test is also used by the researcher to determine whether or not the two independent estimates of the population variances are homogeneous in nature. So we have to find about it. Okay, so you have to see that population variances are homogeneous in nature or not. So that is the reason that we are going to see about it. Now, let's have a look on the example, an example depicting the above cases in which the F-test is applied is, for example, if two sets of pumpkins are grown under two different experimental conditions. In that case, you just imagine two sets of pumpkins are grown under the different experimental conditions. So in that case, the researcher would select a random sampling of size 9 and 11. I hope you are understanding, students. Okay, so just understand that in that way. In that case, the researcher would select a random sample of size 9 and size 11. The standard deviation, the standard the standard deviation, their weights are 0.6 and 0.8 respectively. After making an assumption that the distribution of their weights is normal, the researcher conducts an F-test to test the hypothesis on whether or not the true variance are equal. So just remember, just understand that we are finding out that the variance are actually on the equal side or not. We are just checking that. So variance are truly equal or not in two set of population. We are just looking at that. So just have this example once again, that it is depicting the above case in which the F-test is applied and two sets of pumpkins we have taken are grown under two different experimental conditions. Maybe it is geographical condition, maybe or any environmental condition. So they are grown in different experimental condition. So in that case, the researcher would select a random sample of size 9 and size 11. Random sampling is done. The standard deviation of their weights are 0.6 and 0.8 respectively. So now the researcher has made an assumption that the distribution of their weights is normal. Okay, this is the assumption of the researcher. So the researcher conducts an F-test to test the hypothesis on whether or not the true variances are equal. I hope you are understanding that there are two populations and we have to see the variance equality among them. Variance is the square root of standard deviation. Okay, students, now let's proceed further. So there are some common examples of the use of F-test include the study of the following cases. How the F-test is used. So the hypothesis that the means of a given set of normally distributed population, when the means are given in a set of normally distributed population, all having the same standard deviation are equal. This is perhaps the best known F-test and plays an important role in the analysis of variance, which is called ANOVA. Okay, so analysis of variance is also called ANOVA. The hypothesis that a proposed regression model fits the data well. So this is something, see, lack of fit, sum of squares, how we are going to see that. Now the hypothesis that a data set in a regression analysis follows the simpler of two proposed linear models that are nested within each other. In addition, some statistical procedures such as Sheffield's method for multiple comparison adjustment in linear models also use F-test. Okay, so these are different examples I have given you, students, about how the means, when they given in a different sets, they are normally equal, and when the variance is also equal, how we are going to find, how we are going to test the hypothesis that it is dispersed in a normal manner. Okay, now let's see some uses of F-test, how the F-test is working. So students, I have already told you in my previous slides that F-test is actually used to test the significance of an observed multiple correlation coefficient. So I have already mentioned it in previous slides also that F-test is used by the researcher to see how much it is equally dispersed, how much the data is there equally dispersed around the mean or standard deviation. So the researcher uses the F-test to test the significance of an observed multiple correlation coefficient. It is also used by the researcher to test the significance of an observed sample correlation ratio. Okay, so understand it in that way also, that when we have a sample, when we have observed a sample or two samples, so what is the correlation ratio in that? So when there are two or more groups and we have to see the multiple correlation in that, so how can we judge that? So F-test is best when we all know that when we have to see the significance of two groups, then we apply t-test. But if there are multiple groups and there are more and more correlation we have to see, then the significantly the researcher uses the F-test to check it out. It is also used by the researcher to test the significance of an observed sample correlation ratio. The sample correlation ratio is defined as a measure of association as the statistical dispersion in the categories within the sample as a whole. So its significance is tested by the researcher. All right, students. So just remember, F-test is also another very important part in the research when we are going to give the statistical treatment to our data. So understand it in that way. Now, another use is the researcher should note that there is some association between the T and F distribution of the F-test. Okay, so there is some association between the T and F distribution when you see the t-test and when you see the F distribution. So according to this association, in a statistic T follows a student's T distribution with the n degrees of freedom, number of degrees of freedom. So then the square of this statistic will follow Snedeker's F distribution with 1 and 1 n degrees of freedom. So the F-test also has some other association, like the association between it and chi-square distribution. Now students understand this, that due to such relationship, the F-test has many properties like chi-square because it is analyzing so many things. So the F values are all non-negative. The F distribution in the F-test is always non-symmetrically distributed. So the mean in F distribution in the F-test is approximately 1. Just remember, the mean in F distribution in the F-test is approximately 1. There are two independent degrees of freedom in F distribution, one in the numerator and the other in denominator. So denominator and numerator both are having equal importance. Both are having importance in the F distribution. So there are many different F distributions in the F-test. One for every part of degree of freedom, and so this is something that you must remember, that such relationship is established. So properties of F-test is like chi-square, number 1. The number 2, the F values are all non-negative, and the F distribution is the F-test is always non-symmetrically distributed. And the mean in F distribution in the F-test is approximately 1. Just remember the value, it is 1. So there are two independent degrees of freedom in F distribution, one in the numerator and the other in the denominator. So this is somewhat the uses of F-test we have discussed. Now students, let's have a look on the characteristics or features of F-test. Why it is so important, and why when you are using the statistical treatment, why it becomes so necessary for a researcher when the researcher is studying 2 or more groups. So the F-test is a parametric test that helps the researcher draw out an inference about the data that is drawn from a particular population. So F-test is known as parametric test, and the data is collected from a particular population. So these are the important characteristics, because the data what we have collected, the results will be taken out from them only. Then the next thing, the F test is called a parametric test. Why it is called parametric? Because of the presence of parameters in the F test. And these parameters in the F test are the mean and variance. So if this is also the another very important multiple choice question, that what are the parameters found in F test? So the correct answer is mean and variance. So the mode of the F-test is the value that is most frequently in a data set, and it is always less than a unit. So remember, students, that F-test is a parametric test, and F-test is applied when the results, when the data is actually collected from a particular population, and inferences about the data is drawn from that. And it is called parametric test because of the presence of different parameters in the F test. And what are those parameters? It is about mean and variance. Okay, variance, again I repeat, is the square of standard deviation of a particular population, particular group. So the mode of the F-test is the value that is most frequently in a data set, and it is always less than a unit. Now, another important feature, another that is according to Carl Pearson's coefficient of skewness. So the F-test is highly positively skewed. When we see the normal probability curve, students, NPC, when we see the normal probability curve, then F-test is highly positively skewed. So the probability distribution of F increases steadily before reaching the peak, and then it starts decreasing in order to become tangential in infinity. So just remember that Carl Pearson coefficient, according to that, F-test is highly skewed. In NPC, when we show it on the normal probability curve, when the data is shown in that way. So the probability distribution of F is increased steadily. It increases very gradually before reaching the peak, and then it starts decreasing. So it is going up and then it is going down in order to become tangential at infinity. Then it becomes infinite at the rest. Thus, we can say that the axis of F is asymptotic or the right tail. So right tail we get at the last, where the actually it is decreasing. Okay, so it is positively skewed in that manner. Now again we are going to see some characteristics or features of F-test. An F-test is any statistical test in which, students, the test statistic has an F distribution. Under the null hypothesis, the researcher chooses the null hypothesis, where he or she decides that there is no significance between the groups or 2 or 3 groups. So it is there when any statistical test is applied to that. So it is most often used when comparing statistical models that have been fitted to a data set in order to identify the model that best fits the population from which the data were sampled. So again, understand it in a more simpler way, that it is most often used. The F-test is very commonly used when comparing statistical methods that have been fitted to a data set, or one type of data, one particular sample, in order to identify the model that best fits the population from which the data was sampled. So exact F-test mainly arise when the models have been fitted for the data using least squares. Okay, so the name, I again tell you, it was coined by F-test was coined by George W. Snedeker, and in honor of Sir Ronald A. Fisher. Ronald A. Fisher. Fisher initially developed Fisher initially developed the statistics as the variance ratio in 1920. So the name was coined by George W. Snedeker. Just remember these two names in honor of Sir Ronald A. Fisher. Now, F-test of the equality of two variants. How we are talking about it, and from the beginning that F-test is used for the finding out the true equality of two variances from two or more groups. Are they Are they equal, or are they applying the same thing? So the F-test is sensitive to non-normality. Okay, so and in the analysis of variance, when we do it, ANOVA, when we check it, alternative tests include Levin's test, Bartlett's test, and the Brown-Forsyth test. So these are some other tests to check the ANOVA or the variances. However, students, when any of these just a second. However, when any of these tests are conducted to test the underlying assumption of homoscedasticity or homogeneity of variance as a preliminary step to testing for mean effects, there is an increase in the experiment-wise type 1 error rate. Okay, so this is about F-test of the equality of two variances, that it is the sensitive to non-normality, and it works in the ANOVA also. Now, let's see the formula and calculation, how it is done. So, students, most F-tests arise by considering a decomposition of the variability in a collection of data in terms of sums of squares. So variability in a collection of data in sums of squares is decomposed, and it is considered when the F-test need of F-test is actually felt. So the test statistic in an F-test is the ratio of two scaled sums of squares reflecting different sources of variability. So these sums of squares are constructed so that statistics tends to be greater when the null hypothesis is not true. So when the null hypothesis is not true, so sums of squares are constructed so that the statistics tends to be greater. All right. So in order for the statistics to follow the F distribution under the null hypothesis, the sums of squares should be statistically independent, and each should follow a scaled x square distribution. So this has to be remembered by you, that how it is done. So the later condition is guaranteed, students, if the data values are independent and normally distributed with a common variance. Okay, so this was about formula and calculation. Most F-tests arise by considering a decomposition of the variability in the collection of data in terms of sums of squares. Now let's have see the multiple comparison ANOVA problems. So when we actually see the correlation between multiple groups, so what are the problems that basically a researcher feels? So the F-test is one way. Analysis of variance is used to assess whether the expected values of quantitative variable within several predefined groups differ from each other. So expected values of a quantitative variable within several predefined groups differ from each other. So in that case, when F-test is applied, then the researcher might face the problem. For example, suppose that a medical trial compares 4 treatments. Okay, so there is a treatment of any disease is being given to the patients, and there are 4 type of treatments. Now you simply have to find the correlation between among these 4 treatments that are running simultaneously on the patients. So ANOVA F-test can be used to assess whether any of the treatment is on average superior or inferior to the other versus the null hypothesis that all 4 treatments yield the same mean response. So just understand it in another words, students, that when we take out the mean of every treatment, when we are applying the treatment on the patients, we have a set particular data for that. Maybe 50-50 patients are there in all the 4 treatments, and then we have got the mean value. And now F test will be enabling you to assess whether any of the treatment is on an average superior from the mean value or the inferior from that mean value. So that is the case that you will be going to accept or reject your null hypothesis in that way. Now, this is an example of omnibus test. So, omnibus test is something that meaning that a single test is performed to detect any of several possible differences. So, omnibus test is there, and that a single test is performed to detect any or find out to several possible differences if they are or not. Alternatively, we could carry out pair-wise test also among the treatment. And for example, in the medical trial example with 4 treatments, we could carry out 6 tests among pairs of treatment. So this is something that can be done simultaneously when it is being done. Now students, let's see the advantage of ANOVA test is that we do not need to pre-specify. We can't pre-specify which treatment are to be compared. And we do not need to adjust for making multiple comparisons. So what is the need? So simply advantage of F-test is we do not need to just pre-specify, or beforehand we are going to specify that okay, this number 1 treatment is best for the patients, and number 2, number 3, number 4. Or you can give different coding X, Y, Z, or any A, B, C, T coding that these treatments are not good. So which treatments are to be compared, and we do not need to adjust for making multiple comparisons. All right. So the advantages of the ANOVA F test is that if we reject the null hypothesis, we do not know which treatments can be said to be significantly different from the others. So we really don't know that which are significantly different from the others. So this is the actually a disadvantage, and it cannot be said that either one treatment is fully okay, or another 3 treatments are not different from others. Nor is the F test is performed at level alpha can we state that the treatment pair with the greatest mean difference is significantly different at level alpha. So this is something that students you must remember, that F test is that we do not need to predefine the things that these are we are going to compare and how it is going to be drawn as a result. Okay, so multiple comparisons are made, but we are clear that we do not need to adjust for making multiple comparisons. Comparisons will be coming out as they are. So we do not need to actually preset them. Don't preset them. F-test will take out it itself. Now, let's have a look on the F-test formula. F-statistics is done variance of the group means and oblique mean of the within group variances, and there are different formulas given to it, and just practice will be enabling you to do more proper F-test on your data. Now, significant difference between variances of 2 populations based on small samples drawn from those populations. So S1, N1 is F equals to N1 minus 1 upon S2 square N2, N2 minus 1. In the F ratio, we always take the larger of the 2 estimates in the numerator and smaller in the denominator. Okay, so this has to be remembered by you when you are applying the formula. You take the larger of the 2 estimates in the numerator, that is upper side, and denominator is at the lower side. So the degree of freedom is N1 minus 1 and N2 minus 1. Now, what are the assumptions lying down behind the F test? So students, as a researcher, I know you will be doing hard work for your research work, your dissertation, your thesis work, and you will be applying your data, and you have selected your hypothesis in a very refined way. But what are the assumptions when we are using any particular test? So several assumptions are made for the test. Your population must be approximately normally distributed. It fit the shape of bell curve. The bell curve is actually is a best curve in NPC, normal probability curve, in order to use the test. Plus, the samples must be independent events. In addition, you will want to bear in mind a few important points along with that. So, first of all, it assumes that your population is normally distributed. Whatever the population you have taken, all the units are equally distributed. There is no difference in that. So there is like bell curve is the best curve which is considered a normal probability curve. So it is actually expected from your population to have that. Okay, so the larger variance should always go to the numerator and the top number to force the test into a right tail test. Right tail tests are easier to calculate. Yes, one more important MCQ or one more important question comes for the net examination aspirants, that which tests are easier to calculate. So the correct answer is right tail, left or right. So when the distribution is going towards right side, it is easier to calculate for the researcher. So the larger variance should always go in the numerator on the top number, which I told you, top number, larger number, and the down number would be the smaller, little smaller number. So it is assumed. So these are the assumption when we do the F test. Now assumptions for two-tailed test. Divide alpha by 2 before finding the right critical value. When you're having two-tailed test, divide your alpha value by 2. Whatever the alpha value you have got from seeing the table, you divide it by 2 before finding the right critical value for your test. So these are assumptions that as a student you must, as a student or an investigator, you must find out. So if you are given standard deviations, they must be squared to get the variances. You are given standard deviation, but you must square them. You must square your standard deviation to get the variances. Only then you will be able to find the significant difference of your groups through F-test. So variance is very important in F-test. So if you are not given the variance, if you have not taken it out, just do it. You can do it through computerization or you can do it by your own. But I know everybody is not so much mathematical sound, and sometimes math seems a mess to so many people. So this is somewhat a good suggestion from my side to use the computer and then get the variance. So if your degrees of freedom aren't listed in the F table, so F table, if your degrees are not listed, use the larger critical value that you have got. So by dividing the alpha with 2. So this helps to avoid the possibility of type 1 error. Type 1 error and type 2 error is actually related to rejection or selection of hypothesis, and when it is true and when it is not true. In that case, you have to go in with detailed studies of type 1 error and type 2 errors. Now, these are some references, students, for your purpose, and you can study more about F-test by looking at these references. Now, let's discuss some MCQs given to you with explanation also. So, the question 1 is related to this set of probability and statistics, multiple choice questions and answers. Focuses on F distribution. So the question is the mean of the F distribution is equal to V2 divided by V2 minus 2 for V2 is greater than 2. So there are A, B, C, D, 4 categories are given. and the answer would be the mean of the F distribution is equal to, that is related to A, option A, and would be the right explanation for this answer, that the mean of the distribution is equal to V2 oblique V2 minus 2, and then it is V2 greater than 2. So denotes the degree of freedom of F distribution. Okay, then variance is equal to V1 plus V2 minus 2 oblique V1 V2 minus 2 square multiplication V2 minus 4 for V2 greater than 4 for F distribution. Is it true or false? So correct answer, it is false, because variance is equal to 2 multiply V22 multiply V1 plus V2 minus 2. Then oblique V1 multiplied V2 minus V2 or V2 4. So this is the distribution where V1 and V2 denote the degrees of freedom for F distribution. Now, third question is related to which of the following distribution is continuous. So we have four types of distributions: binomial distribution, hypergeometric distribution, F distribution, and Poisson distribution. Then correct answer is C, that is F distribution. So now let's have a look on the explanation, students, that binomial, Poisson or hypergeometric distributions are discrete distributions. Discrete where the data is scattered. Only F distribution is continuous distribution in the given distribution. That means one after the another series is continued. So this is the explanation that F test is, or F distribution is considered as a continuous distribution in given distribution. So this is all about F test from my side, students, and we have seen what is F test and why it is used. F test is actually used to see the equality or truly equal variance is there or not in two or more groups. So correlation is seen. We have seen about the important characteristics of F test, how it is used and why it is used, and then we have also seen the basic assumptions behind that, and the most important assumption behind the F test is that the population is actually normally distributed. That means all the units of the population, whatever the sample we have chosen, all the units have same thing in that. So this is something you must remember. F test was it was given by the name in the honor of Fisher. You must remember it. Okay, so bell-shaped probability curve is always good, which is found in F test. So students, remember about F test and learn more about F test, and just after looking at my video, you can just see and revise your things. So this is all from my side in today's class, and I hope you have learned well through this, and you will take care and remember what is F test and how it is used, and do a good and proper research and apply this statistical treatment to your data to get the good correlation in your multiple groups when you are looking at that. Okay, so remember, variance is always important, and when you are not having variance, you have to take it out by making the squares of the standard deviation. All right, students, so take care, have a nice time, all of you, be healthy, be safe.